Good evening, folks. Well, before we launch into this video, I'm just tack this little bit on the end because I kind of forgot to turn the heater off, and so there's a bit of hum in the audio in the coming video. So apologize for that. But of course, you're already used to my crappy audio, so that won't come new to you. But anyway, the other thing that this video has a bit of physics in it, like, you know, the real thing, okay? So you might not be interested in the physics, so when you hear me talk about Faraday, you can just skip over about, I don't know, 10 minutes or something like that. Or you can just listen to it, and learn something, if you don't already know about magnetic induction. Okay? All right? Let's get into it. Oh, before we do that, take it right to the end. There's a lot of fun to be had. Okay? All right. Let's get on with it. Well, good evening, folks. Here we are back again to talk about flat earthers. Okay. Well, this particular video is, if you like, a carry-on from one I did previously on models. And it seems that that wasn't sufficient information for some flat earthers, because they continue to insist that a model is some kind of truth. Now, there's two of them in particular that I'm referencing. There's one chap called Dell, and Dell goes on a rampage once a week, and in recent times more often, claiming that people who believe that the Earth is a sphere are morons, and that the idea that the Earth is a sphere is just some sort of concept. The other one is a chap called Andrew, who hangs around my channel and wants to troll me every now and then, and he thinks he's a bit of a smarty. Well, I'll tell both of you this. If you both actually believe the Earth is flat, then smart is not one of your strong points. Okay? Let's get that right. Okay, now, so what is a model? Well, first of all, a model is nothing to do with truth. Okay? It's, if you like, an idea. Model, in two words, is a what if. What if we put together an idea, and within this idea we set some parameters? Parameters that will tell us various things. Okay. Recently, a little child of a friend of mine said to me, "Professor, what is a model?" I said to him, "Well, let me put it like this. If you had a factory that was making, let's say, 2 widgets every minute, and it happens that on a particular day you've got 100 widgets on the shelf. Well, you could model your widget production, and this way you'd be able to predict how much widgets you'd make in a certain amount of time. Presumably, in this case, it would be a linear relationship. Okay, where t is the amount of time, the gradient is the amount of stuff that you made for a given amount of time, and the constant is what you started with. That's your model.
you can use your model to predict how many widgets you'd make. Now this is only a little kid, 8 years old, and he got it. Actually derived the model himself. So it can't be that hard. And yet for flat earthers it seems to be. Okay, so what do they say? Well, first of all, before I get on to that, again, just to reiterate from that little story about that kid, the model gives us outcomes and predictions. And those outcomes and predictions are the outputs. That comes from inputs into the model, which you've developed, and then you get the outputs are predictions. That's what makes the model useful. Now, if somebody comes along and makes a better model, if there's a better model for exactly how many widgets are made, well, that's good. Okay, no one's going to complain if there's a better model. They're going to adopt it if it's a better model, if it makes a better prediction. Okay, maybe the graph that for the widgets just doesn't stretch far enough. So maybe we want to make a better graph, maybe a more accurate one, so that you can more accurately predict how many widgets are going to be made. Or maybe you could just throw that one out altogether. Maybe you can just change how many widgets you make every minute. Then you'll have a different model, won't you? Still be roughly the same though. Still be a linear relationship. Eh? Okay. So what do they say? They say we don't live on models. Well, duh. Why wouldn't you even say something that stupid? Of course we don't live on models. Although we can model the place where we live. That doesn't mean we live on the model. We're just modeling what the place we live is like and how things around it work. Models are accepted as truth. This is the fundamental problem with flat earthers. Like this Andrew guy. He says, I'm supposed to do an experiment that proves that the earth's spin and proves that the earth is a sphere. Well, I most certainly can demonstrate those things. I can certainly provide evidence that verifies those things. But I'm never going to give you anything that's called proof. Proof does not happen in science. And certainly truth does not happen in science. Because as soon as you discuss truth, as I've said before time and time again, you now have locked it in. Because truth is a very definitive word. It locks in what you have. And that's not how science is. Because in science, we expect things to change. And most certainly they'll change at the fringes. Okay. So I thought, oh, here's another one. Models are lies. Another ridiculous statement. How can a model be a lie? How can an idea be a lie? It seems like people in flat earth don't know what the word means. It means you deliberately keep something away from somebody. You deliberately tell something different to what you believe the reality is. Even if I believed something, that doesn't mean that I'm lying about it. If I believe it, then I'm not lying. Okay? So let's get that straight at least. Now, a model isn't a lie because it's an idea. It's an idea that can change. So, this nonsense that people are going around, globe lie. What kind of bullshit is that? It makes no sense at the outset. It completely proves that you have no idea what you're talking about. Alright, I thought we could learn a little bit of physics in this particular one. Why not? So let's look at a model called the ideal transformer. So back in 1831, Faraday had a circular wooden ring, and around each side of the ring, straight across, he put two coils, and on one coil he connected a battery, and another coil he connected a galvanometer to measure fluctuations in current. And sure enough, when he flicked the switch on the battery side, the galvanometer flicked, registered current. And this was kind of strange to him. I mean, you know, he did it because he was expecting something, but still, even then, that was strange because there's no physical connection and no electrical connection between those two coils. And this was a piece of wood, so it was an insulator. It didn't have any magnetic properties or anything like that. So it was just a piece of wood. Well, he took that a bit further and used an iron core. So like this, okay, and this iron core, and then put the coils on each side of that, and discovered that if he used AC voltage, it stayed on, which was fantastic. But more than that, he discovered that the amount of voltage that you got on the other side was proportional to the number of turns that you had on one side of the frame compared to the other. So, if you had 24 volts, for instance, and 6 turns on one side, you'd get 12 volts with 3 turns on the other side. That was bloody handy, because not only did it work that way, so that was called a step-down transformer, but it actually worked the other way. You could put 3 volts in on one side with 3 turns and grab if you could 12 volts in on one side with 3 turns and grab 24 volts out of the other side with 6 turns. That was really, really handy. Now, this was just a model. What would it do in real life? Well, turns out in real life, when you actually had to do this and use it in a large circuit, you found that it didn't quite do what was predicted. So you didn't quite get the power that you wanted. You didn't quite get the voltage that you wanted. And of course, the reason for that is because of resistance of the wires, and also the properties of the core. And one last thing, discovered that some of the energy was lost in the actual stem of the core, like that. Some of it was lost over there in little current eddies. So, one of the ways to fix that was to chop this into many slices. So, chop that core up into many slices and sandwich them together with insulating materials. And that not only reduced the amount of, dissipated the heat better, okay, but it stopped those eddies from happening and made the transformer more efficient. So in other words, you got more out of the power that you put in. Again, there's a model improved upon, and it worked better because it was improved at the edges. Okay, well, Why did this all happen? I guess you probably should asking if you don't know anything about transformers. And this is called induction, by the way, okay? Magnetic induction. And the way this was working was that, see, if you put any ferromagnetic material like iron into the middle of a coil, it's going to create a magnet. I'll show you something. See this? This is one. This is a coil. So if this was a magnet, not a magnet, just a normal piece of steel, and this was connected to power, say a DC power, you push that through, came out the other end, that would create, if that was connected, this would become a magnet in here. Now, by the same token, if this was a magnet already and had a magnetic field and you pushed it through, you would create a current across here. Quite amazing. Okay. Alright, so this was a model. It's tweaked at the edges and works. What about the Big Bang and evolution? Again, a couple of models. People wondering, how did this all start? How did this universe all start? Well, you know what? Let's have a look at the evidence. We see blue shift, we see red shift. We see that the thing is expanding. And we think, well, you know, if it's expanding, then more than likely it started from somewhere. It started expanding at some stage from something much, much smaller. Now, if we consider that a model where things started from very, very small, then we could conceivably see how elements were created. Because, I mean, we're looking at this model and we're saying, well, everything's expanding out from it, so therefore it's likely that it started from some place, you know, some small place. But then that didn't in itself explain how elements were formed. But when we brought that down to in the Big Bang Theory and looked at how this started as a singularity, as energy, and then especially after the work that Einstein did, where E equals mc squared, and looked at that, I thought, well, you know something? That explains how elements are formed. So that's a terrific model. That really does explain it. And so far, no one's been able to come up with a better one. And until they do, that's a pretty good way of explaining it. Is this the truth? No. Why should it be? It might change. It can't be the truth. Okay, we'd never know if it was the truth, because we'd never know. Down the line, I don't know, I'd be dead, and maybe in 1,000 years someone will come up with something better, with a better explanation from it, and they'll nail it. And still that won't be the truth. Okay, so it's never going to be that. That's not how modeling works. That's not how scientific models are. Okay. Evolution. Same deal. We look at that and we think, well, maybe it was made from nothing. Eh? I mean, flat earthers are always accusing us of saying something came from nothing, which we never say. We always say it started from a singularity, but we never say it comes from nothing. But I tell you who does say things come from nothing. Flat earthers. Because they've got this God out there. They've got this creationist. And this God says, poof, a giraffe, poof, a lion, poof, a mountain, poof, the sun, poof, the stars. Out of nothing. Did he have something in his hand to start it off with? No. Huh? That's not what you say. He just, what did he do? Flick his fingers? Go, poof. Stars. How good is that? That's what I call making something out of nothing. Hey? Okay. So, evolution, we see amino acids, and they change spontaneously into peptides, and these change into long chain proteins. These are all possible. So all the things that are needed for the building blocks of life are all possible in chemistry. So we look at that and think, well, you know something? We don't need this magical creator. Okay? It's more than likely that's not how things started. And just maybe there is a magical creator who said, poof, let there be amino acids. Well, no. The Big Bang explains amino acids already. So, no, you don't even get that much. Okay. What about gravity? Gravity with Newton and Einstein, totally misunderstood. First of all, I'm going to lead with this, just so you get this into your thick heads. Because people like Sleeping Warrior and the Big Queen, yeah, you know who the Queen is, say stuff like Newton dispensed with, Einstein dispensed with Newton. Einstein disproved Newton. Well, here's something you probably didn't know. Because of course you don't know anything about maths, do you? In fact, you don't know anything about physics. In fact, you don't know anything much about anything, do you? G is in Einstein's field equation. And guess where that comes from? And one of the things that Einstein was very careful to say, and that Newton is one of his heroes. So get that into your thick heads and stop saying that nonsense. Okay? Alright. Okay, so shape of the earth. Well, I reckon the horse is bolted on that one. I'm still not going to say truth. You know why? Because there are things about the Earth's size and mass and all that that could change. You know, we've got a pretty good idea what size it is, and we've got a pretty good idea what shape it is, and what the mass is, and what it's made of. But, you know, those things can change at the fringes. But that's about as much as it's going to change. You know why? Because we've seen pictures of it. Alright? Okay? You know, like with those things called cameras. Yeah. You like cameras. Like you've got this P900. Right? That was nearly made by a poof from a creator. You love it that much. Eh? Well, that's a camera. And you always seem to believe in the things that you see with this camera. Well, you know, we have other cameras, even better than that one, hooked on the side of rockets and in the payload bay of rockets. You know, like when the satellite gets deployed, to the side in the payload bay gets to watch this. And then we get to watch it because it's a camera. Yeah, even better than a P900. Okay, so what's this nonsense about the Earth not being a sphere? We've seen the pictures of it. Okay? It doesn't have to be CGI. You're just making that up. Because you know right there and then, that stuffs you right up. Now why you didn't figure that out in the first place when Eric Dubay was spilling out his nonsense is beyond me. Okay, let's carry on. Well, flat. Now, Dell goes through great pains to try and differentiate between level and flat. So he thinks that level means straight. Straight means level. Nope. And Dell, no matter how many times you say it, it doesn't. Level means the same distance, the same elevation. Guess what elevation means? Same distance up at sea level, for instance. Okay, same distance here at sea level up, same distance over there. Okay, so, and which actually means the same distance to the center of Earth's mass. That's what level means. What you're thinking of is called flat. And water is never, ever flat. Okay? And you ask, why can water be used for building and construction? Well, yes, it can, because it's got that fluid that gives us the same level in both tubes. Well, because it's a fluid, yeah? Okay? We could probably use better fluids than that, but, you know, like water is pretty cheap and not dangerous to handle, so it's a pretty good one to use. So, we put water there, it comes out level. That doesn't mean that it's flat, it just means that over that short distance, the difference is so tiny, it's indiscernible. You would not have the instrument to be able to tell, to discern that tiny, tiny, tiny difference. And it certainly wouldn't make any difference to your building, or your concrete slab, or your brick wall. Okay? But it's not flat. It's level. Okay. Now, sometimes we do actually model flatness. And the reason for that is because the people who do that realize that this difference is so tiny, it doesn't bear thinking about. No use including it in any calculations. Just forget about it. It's just too small to worry about. So, Euclidean geometry is fine. That'll work fine. You can just reduce all of this to 2 dimensions. Then you don't have to worry about the curvature of the Earth, because the distance that you're dealing with are too small to worry about. So what if a building's out by a millimeter in 10 yards or in 10 meters or whatever? So what? You think that makes a difference? No, I don't know the precise amount. I would be able to calculate it, but just to let you know, it's tiny. And because it's tiny, it doesn't matter. Okay? You can actually make some really good predictions based on a modeling Euclidean model. Okay? Just 2 dimensions is fine. I'll tell you when you do this all the time. And you seem to accept it. And I agree with you to a point. You see, because you tell everybody that if it were a globe, then it would be 8 inches per mile squared. That would be the fall. Okay? Well, that's a parabola. That's not a circle. Okay? That's not the equation for a circle. Now, the Cartesian equation for a circle is x squared plus y squared equals r squared for a circle. Okay? That's nothing like this. So, there you go. If you're going to go around saying that 8 inch per mile squared is good enough, which it is over a short distance, you know, maybe even as much as 100 kilometers, you would probably do, because the difference is so small it doesn't matter. But any more than that, it's exponentially wrong, because it's a parabola. Okay? Now, how come you didn't know that? How come you didn't know it was a parabola? Well, unsurprisingly, you barely know what an equilateral triangle is, do you? Okay. Finally, that research nonsense that you talk about, your research. You know, this is where you go off to your queen to get some more info. Huh? Some more bullshit. See, because the queen knows that the queen's handing out bullshit, but they need to hand out new bullshit all the time. Well, you know, they just tack on a little bit and call it new, because actually nothing's new. We hear the same stuff over and over again with a little bit extra smell attached to it. Eh? That's what you do. That's what the queen does. Just puts an extra bit on it. Comes up with this black swan nonsense, which got knocked over in about 5 minutes. Okay. You know something? I think you're all having us on, eh? You just can't be that dumb. I don't believe it. I reckon most of you are pros having us on. Okay, that's enough for this video. If you like this video, press the subscribe button if you haven't done it already, and I'll be making more, because I'm going to actually address those drones one at a time. Okay, there's plenty to be said about them, plenty of fun to be had. Might as well. Okay, so press that subscribe button, and don't forget to press the bell so that you're reminded when you see another one of these. And if you liked it, press like. And if you disliked it, smash the dislike button. Okay? Alright, I'll give you a couple of seconds to do that. On your marks, get set, go. Press. Good on you. Cheers.